NCRT Class 11, Chapter 10, Fluids, question number 10.2. Again, we have been given 5 points to explain. The first one says the angle of contact of mercury with glass is obtuse, while that of water with glass is acute. Now, for A, we can show that let us suppose this is the wall of the container in which mercury is kept, and let us consider a molecule over here. Now you see this molecule experiences the force of attraction because of the molecules of the glass, and that is the adhesive force. This is the molecule, this is experiencing force like this, and the resultant of all these forces comes towards left, and this is right side Fa. Now if this is the liquid boundary, it is going to experience the cohesive force of the other liquid molecules, and the resultant of these forces come over here, let us suppose Fc. Now in case of mercury, the cohesive force is much higher in comparison to the adhesive force between mercury and glass, and thereby the resultant of these two forces comes out to be over here somewhere. Now if the resultant is over here, then in this direction the liquid surface will be perpendicular to this resultant force, and thereby it will turn up to be having a curved shape like this near the boundary. Now if you talk about the angle of contact, though, this is the tangent to the surface inside the liquid, and this is the tangent to the free surface. Yeah, and if you can see the angle between them, this angle is obtuse. Now when we talk about the case of glass and water, then in this case again I consider water molecule over here. This is again the adhesive forces on that water molecule, and the resultant is over here Fa, and it is going to experience a resultant cohesive force over here because of its own molecules. Now in case of water and glass, the adhesive force is much stronger, thereby the resultant is over here somewhere, and again the free surface is going to take a free shape which is perpendicular to this resultant force, and thereby the free surface is like this. Now again if I draw two lines like this, then you can see the angle of contact in this case is acute. Now next part, that is B. Water on a clean glass surface tends to spread out. The reason is again the cohesive and the adhesive forces. For example, this is a clean glass surface, and we have kept a liquid drop, water drop over here. It takes a shape like this because the angle of contact is acute. This is your angle theta. Then you see that the molecule on this boundary will be experiencing adhesive forces towards right, and there will be a tangential force, of course, cohesive like this. And since adhesive forces is higher, and thereby you can see it is going to spread out in both all directions. Now when you talk about mercury on glass, if you have seen that mercury tends to take spherical shape like this. Now again if you consider a molecule on this boundary over here, it is going to experience cohesive force like this, and adhesive force will be like this, and thereby you can see that Fc is more than force adhesive, and Hg will tend to form a spherical liquid, and thereby it will not be wetting the glass surface. Now next, it says surface tension of liquid is independent of the surface area of the surface. Now we know that surface tension is defined as the force per unit length on any line considered on the liquid surface and it is in direction normal to it. Now, since the force is independent of surface area, thereby I can also say that the surface tension will also be independent of surface area. Now, next is D. Now, it says water with detergents will dissolved in it should have small angles of contact. Now, we know that the height of capillary rise is given by twice sigma cos theta by rho rg. Now, if the angle theta is small, then the cos theta will be large and thereby the h will be large. So if theta is small, then this will give you cos theta to be larger and thereby h will be large. And thereby you can say that the penetration of detergent in air capillaries of clothes will be more. Next is E. A drop of liquid under no external forces is always spherical in shape. Now we know because of surface tension, we know that the free surface of a liquid behaves like a stretched membrane and tends to have minimum surface area. Thereby, for a given volume, the sphere has minimum surface area. So I can write because of surface tension, free surface of liquid tends to have minimum surface area and for a given volume sphere has minimum surface area, and that is the reason for the liquid drop to take spherical shape in absence of external forces.